So on this free body diagram, I'm told that the body is 3.0 kilograms, and once again, armed with this information, I can figure out force weight because force equals mass times acceleration. So force weight equals mass, which is 3.0, times the acceleration due to gravity, which is negative 9.8 meters per second squared. When I do the math, I get force weight to be negative 29.4 newtons. Because it doesn't say that the body is accelerating towards the center of the Earth, I get to say that force normal is positive 29.4 newtons. So that takes care of the y-axis. It is in equilibrium, but now there is a net force in the x-axis, and I can figure out what that net force is by using F net equals mass times acceleration in the x-axis. Now the problem tells me that the mass is 3.0 and acceleration in the x-axis is 2.0. So my force net has to be 6.0 newtons. The problem is I have a force applied of positive 13 newtons. So I can use this information to go figure out what the force of friction, or the force to the left, is. Force net equals all the forces to the right plus all the forces to the left. I found force net to be 6.0 newtons. The forces to the right are positive 13 newtons, and I don't know what the force to the left is. In order to get forces to the left, I'm going to subtract both sides by 13 points. Subtract 13.0, and I'm given a force in this direction of negative 7.0 newtons. So that means that the force friction is negative 7.0 newtons. Armed with this information, now I can go figure out coefficients of friction, which I call mu. In order to do this, I find that physics is fun. So I take that force net and I answer my question, but now I need to go solve for mu. So physics is fun. Force of friction equals mu kinetic times force normal. Because it's moving, I know that it's friction kinetic and mu kinetic as well. So the force of friction kinetic is negative 7, and that equals mu kinetic. Now you'll notice I put the negative 7 in red. That's because it's in the x-axis, and I put mu kinetic in red as well. Well, actually, I should put mu kinetic in black because it doesn't have a direction technically, but force normal does, and that's 29.4 newtons, and it's in blue. I'm going to divide the right side by 29.4 in order to get mu kinetic all by itself. Whatever you do to the right, you have to do to the left. When you do this math, you get mu kinetic equals. Now technically this should be a negative number. I choose not to write it as a negative number because I know that mu's cannot be cannot be negative. I get 0.023809.5, and then in order to make it nice and neat, I'll round to the second decimal place, 0.24.